Teacher Jaymar, and in this video we will be discussing all about the first topic in general mathematics. If you are an upcoming grade 11 student, then you should watch this video. Join me and it might help you in your struggles in math. Let us start. By the way, for those who are new in this channel, don't forget to subscribe. Okay, let's start.
Presentation graph of a special function. The first special function that we have is the linear function. From the word linear, the graph is a line, and it will be a linear function if the form is f of x equal to ax plus b, wherein this a and b are real numbers. And if we focus here, it is just the y equal to mx plus b. This enters a slope-intercept form. So if you are given with the slope-intercept form, we can easily graph the function. How? Okay, let us consider an example. Example: find or sketch the graph of the function f of x equal to 1/2 x plus 1. So what we will do first is to determine the intercept, the y-intercept, the point of intersection between the graph of this function and the y-axis. So it should be the 0b, where b here is 1. So we are certain that our graph will pass through this point. At the same time, our slope is 1/2, so it means our slope is 1/2, and slope is rise over run. It will rise once and it will run twice going to the right, because this is positive. And if the slope is negative, it will rise once and it will run to the left twice if it is negative, but here it is positive. So let us graph. To graph this, it is just somehow like this. 0, 1 is somewhere here. It's 0, 1. Okay, this is the 0, 1. It's the point 0, 1. It will run rise over run, so it will run once. It will rise once rather, and it will run twice. 1, 2, 1, 2. So the other point is somewhere here. Okay, I will repeat. So the starting point is 0, 1. The slope is 1/2, so rise once, and it will run to the right twice. 1, 2. So this is the other point. If you have 2 points from your Cartesian coordinate plane, and if you connect the 2 points, then you can create the line. And that line is this line. Okay, so that is the graph of that linear function. All you need to determine is the intercept and the slope. The next function, constant function, and it will be a constant function if the form is written in the f of x equal to any constant, say k, or in this case is any real number. So if we consider the linear function that we consider in the first function, special function, it is just f of x equal to ax plus b. If the value of a is 0, then it is also 0. So it means you only have b, or somehow any value of the k. Okay, so it means a constant function is a linear function. It means the graph is a line, but it is more easy to graph than the other linear function, because constant function, you will just determine this k. So example, you are asked to graph f of x equal to 3, f of x equal to 3. So it is not clear. F of x equal to 3. So what you will be doing is, for any value of x that we have, the result is always 3. Y is always 3, or f of x is always 3. So it means the value of y is always constant. So what we will do, we will just count 1, 2, 3. So if that will be the case, if this is 3, you will just draw a line along 3 in your y. And this is now the graph of f of x equal to 3. This f of x equal to 3. And if the value here is negative, example, f of x equal to negative 5, so for example, f of x equal to negative 5, f of x equal to negative 5. So the graph will be somewhere here, 1, 2, 3, 4, 5, negative 5. So you will just draw this horizontal line along negative 5 in your Cartesian coordinate plane, in the y-axis. So that is very easy in considering the constant, or graphing the constant function. The next function that we have is the identity function. The same in the constant function, identity function is also a linear function. It means it can be written of the form f of x equal to ax plus b. And it is an identity function if the form is f of x, from the word identity, whatever is the input, the same with the output, f of x equal to x. So let us consider an example. Let us graph the function f of x equal to x, identity function. So this is an example. So what you'll be doing is this one. The identity function is whatever is the input, the same with the output. It means if the input is 1, the output y is also 1. So you will have this point. The same with 2. If the input is 2 in x, the output is 2 in y. So you will have another this point. If you collect all of those points, then you will have this line. It is a diagonal line that passes through your origin. So that is the graph of the identity function. The fourth function that we have is the quadratic function. So if we have a quadratic function, then probably the graph is a parabola opening up or opening down. And it will be a quadratic function if the form is f of x equal to ax squared plus bx plus c, wherein this a, b, and c are real numbers. So let us consider an example. Graph the function f of x equal to x squared. Is it of the form f of x equal to ax squared plus bx plus c? Yes. Your a is 1, your b is 0 because you don't have x term as well as the constant term. So it means b and c there is 0, are 0. So if we graph this, the graph is a parabola opening up. Why? Because the value here, the 4p or your p is positive in the form of the equation of the parabola. So positive, it means going up. So it will look like this. it's a parabola opening upward, x then y-axis. So quadratic function. The last special function that we have is the absolute value function. Absolute value function. The absolute value function is of the form f of x equal to, of course, the absolute value of x. And the graph of this absolute value function is somehow like a letter V. So it will look like this. If you will see graph having this form, then it is an absolute value function. Okay, absolute value function. Let us have a recap. First, we have the linear function. Linear function, it is a line. Second, we have the constant function. It is also a line, but the graph will be this one. It's a horizontal line parallel to your x-axis. The third is the identity function. Identity function, it means if you have an identity function, your graph will be the diagonal line. The fourth one is the quadratic function. If you will see a parabola opening up or down, it is a quadratic function. And if you will see a parabola or half of the parabola, it's either up or only down part, half of the parabola, it is the square root function. Square root function. And lastly, if you see graph in V form, as in violin, it is the absolute value function. And there are more special functions, but here we only consider 6 special functions. Let us now determine what kind of special function are the following graphs. Sketch of graph. So number 1, what do you think is the graph in number 1? Yes, it is a linear, but more precisely, it is a constant function. Okay, you got it correctly, a constant function. Number 2, what do you think? Yes, it is a quadratic function. Number 3, yes, absolute value function because it is a V. Cubic function, correct? It's only a linear function. Yes, a square root function. A linear function. Also a linear function, but more precisely, it is identity function. And lastly, it is, yes, it is a linear because it's a line, but this is more clear that it is the constant function. So those are the examples of the graph of special functions. Thank you for watching the video. Hope to see you again for the next video. Enjoy.